everyone, and welcome to day one of derivatives. The great news is no more limit definition of to find the derivative. You can now use the shortcut rule, which I know you guys are all going to be excited with. So, the constant rule. If the function is equal to a plain number, the derivative is 0. And why is that? Well, if we have... let's try that again. If we have just a straight line, no, it's not straight, make believe it is, y equals 3, what is the slope of that line? The slope is 0. That's what that's saying. This is just any value, any number that's going to give you a horizontal line, so the slope is 0. The power rule, you should have noticed, if you did not notice this before, that when you take the derivative, we take this power, we bring it down in front and subtract 1. And I know many of you learned that last year. Take the power, move it down, and subtract 1, and there it is. If you have any functions that have terms being added, you take the derivative of each term separately. The product rule, I wrote it out over here. Two terms being multiplied. You get the first times the derivative of the second plus the second times the derivative of the first. That can also be switched, so don't worry if you did the second times the derivative of the first plus the first times the derivative of the second. Does not matter. Commutative property, just excuse me. Make sure that you do first times the derivative of the second plus the second times the derivative of the first. In quotient rule, you're going to do the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. This is the correct way to say it. You want the quick shortcut way, low d high minus high d low all over low squared. Memorize it. Please memorize it. Low d high, low times the derivative of the high. Incorrect terms, but who cares when you're trying to memorize something. Low d high minus high d low all over low squared. So, we've got some examples here. Make sure you realize that that's a constant. If it's a constant, we know f prime of x equals 0. As I was saying before, to take the derivative, you need to take the derivative of each of these. Now, you don't need to actually write this out every time, but know that that's the idea here. So the derivative of x squared, bring the 2 down, subtract 2 minus 1 is 1, so that's why that is there. The derivative of, make sure you realize that that's the power of 1, so 1 times 5 is 5. 1 minus 1 is 0, x is 0 is 1, so that's why we don't have that there. F prime of x here, make sure you realize that pi is a constant, so you're just have the variable of x. The derivative of x is just 1, so we're left with just pi. This one, a nice long one, it looks tough. It's not tough at all. 4 times 3 is 12, x cubed minus 36, x squared minus 10x. Stop. Make sure you realize what's going on. 3, bring it down. 3 times 12 is 36. 3 minus 1 is 2. 2 times 5 is 10. 2 minus 1 is 1. Plus the constant here, square root of 2. Pi squared is not a variable. Pi is a constant, so plus 0 if you wanted to put that down. This is a constant. Everyone wants to say it's 2 pi, just 2 pi. It's not. One way we can redo this one is we can say that's also equal to fx to the negative 2. Well, we bring down the negative 2. Get negative 8. Negative 2 minus 1, make sure you realize it's negative 3, so you get negative 3. We rewrite that because we do not like negative exponents at all. So it's negative 8 over x cubed. With this one, I would not use product rule here, to be honest with you. I would just take this and distribute. So we know that that's equal to 2x to the 4th plus 6x. And so we're left with here the derivative to equal 8x to the 3rd plus 6. Same thing that I would do here. I would double distribute if I was you. So f of x equals, let's see here, 4x to the 7th plus 2x squared plus 12x to the 6th plus 6x. And so I can say that the derivative here, I'll go in order, so we should get 28x to the 6th plus 72x to the 5th plus 4x plus 6. I'm sorry for that being slanted there. So with this one, we have to use quotient rule here. So remember, we have high and low. I'm going to just go with that because I think it's the easiest way to know it. You should be using, if you were to talk about this to anyone, numerator and denominator, but let's just go with high d low, or low d high minus high d low. So again, it's a low d high minus high d low all over low squared. And so we can say f prime of x equals low, x minus 1, d high, the derivative of x plus 1 is 1, minus high, d low, the derivative of that is 1, all over x minus 1 squared. Now please guys, please do not factor out the denominator. X minus x is gone, negative 1 minus 1 is negative 2, and do x minus 1 squared. You're done. Do not factor that out. It makes your life miserable. Just know that. With this one we already did it, but if we were to do it using the low d high method, the quotient rule method, low x squared, d high, the derivative of 4 is 0, minus high, the derivative of x squared, 2x, d low, all over x to the 4th. I just squared it. And you notice that that's gone to 0. So you can get negative 8x over x to the 4th. Those x's there can simplify, so it's negative 8 over x to the 3rd. Notice if we go back here, you'll see that we also got negative 8x to the 3rd when we use the power rule. Clearly, this is the quicker way to do it. Just wanted to show you that you can do it that way. Let's finish this up. F prime of x, low, 80 plus 3x, d high, 2x plus 1, minus high, x squared plus x, d low, 80's gone, you're left with just 3, all over 80 plus 3x squared. So this is going to take a little bit of work to distribute this. Let's see here. Anything we can combine. So you got 6x squared and 3x squared. Subtract those, you get 3x squared. 160, those are gone. So you got with 160x plus 80. Okay. And then one of the last questions, and I do want to go back to show you using the product rule, because I failed to do that when I showed you the easier way to do it. So I do want to go back and do that one. Determine where the tangent line to f of x equals x cubed plus 4x squared plus x is parallel, same slope, to y equals 4x plus 23. We need to find where it's equal to 4. So we're going to take f prime of x, 3x squared plus 8x plus 1. And we're going to set that. We know that f prime of x has to equal 4. So that implies that 3x squared plus 8x plus 1 equals 4. Which implies that 3x squared plus 8x minus 3 equals 0. So let's see here. Can we factor that? Well, the answer is yes. We know that if we factor that, you get 3 times 3 is 9. What factors of 9 subtract to give you 8? Actually, let me do this over here. 3x squared plus 8 plus 9x minus 1x minus 3. So we're going to factor out of 3x, x plus 3, factor out of minus 1, x plus 3. And so we can say that implies that 3x minus 1 and x plus 3 equals 0. So we know that x equals 1/3 and x equals -3 is where the tangent line is parallel to that function. So, just to recap there, tangent line, as soon as you see the word tangent line, take the derivative. Done. Do it. Then you knew it had to be parallel to the equation y equals 4x plus 23. We know that is a linear function. We know the slope is 4. So we set the derivative equal to 4, and then we solved it. That's where we get it. Last one, this is the second derivative. And I hope you guys can tell that this computer gets very slow after doing it a while. So, second derivative, if you can read that. So, I do want to go back and I do want to look at this question. And I'm going to extend the page. I know you guys don't get the lecture to do that, but I do want to do it the product rule way. So, if we look at it, and we're going to get the derivative of the first times the derivative of the second. A few ways to do this, and I just want to show you. So the first, x squared plus 3x, times the derivative of the second, in this case 20x to the 4th, plus the second, 4x to the 5th plus 2, times the derivative of the first, 2x plus 3. And then you could do it out, and you will notice that you would get the same answer. Same idea over here. First times the derivative of the second, plus the second times the derivative of the first. And when you do this out, you're going to get 6x cubed plus 2x cubed plus 6, and you're going to notice, sorry for the poor computer being able to keep up with it, you're going to get the same thing, 8x cubed plus 6. If you struggle with this, I do want to show you the box method. I'm not a big fan of it. I think you should just memorize it, but I do want to make sure that you can see it. Write out the two functions side by side, and then take the derivative of each of them underneath. And then what you're going to do is cross multiply. And I say that, I mean, it's not really cross multiplying, I just say that as the trick. X squared plus 3x times 20x to the 4th, notice that's what we got there, plus 2x plus 3 times 4x to the 5th plus 2. It's what we got over there. So, just so you guys know, that's another way to do it. If you have two things being multiplied, you can write them both out, take the derivatives of each of them underneath, and then cross multiply. Oh, there are your examples of power rule, quotient rule, product rule. Hopefully those you remember from last year, but if you don't, hopefully that was a good recap for you. Joke of the day: what do you call a number that can't sit still? What do you call a number that can't sit still? A Roman numeral. I'll see you guys in class.